Okay, today we're talking about the 30, 60, 90 right triangle. Last time was 45, 45, 90, right? And in that 45, 45, 90, the only two things you had to do besides know that these were the same. If this is 10, this is 10. Then if you want to go this way, you multiply by radical 2, so it'd be 10 radical 2. If you didn't have this one, then you would go backwards and divide by radical 2. So you'd take 10 radical 2, divide by radical 2, and those would cancel and you get 10. Or you could have something that has a 15, something crazy like that. And if you have to go backwards and divide by radical 2, it's going to be a decimal. Radical 2, I think it's like 10.6 or something like that, okay, for these two. Okay, now 30, 60, 90, has two processes, whereas the 45, 45, 90 is either multiply or divide by radical 2. Okay, in the 30, 60, 90, you're either going to multiply by 2 to get the hypotenuse or divide by 2 to get the short side. You've got a short, medium, and large side. Okay, the hypotenuse is the longest side, so it's kind of like Jack in the Box, small, medium, large. Okay, this is the short leg, longer leg, and the longest leg. Okay, so whenever you do these problems, there's this process between this guy, okay, where you either multiply or divide, right, by 2, right? So this is the 2 side. Some people just label this the 2x side, and some people will label this the x radical 3 side before they even start. And then the short side is just the x side. It's kind of like the base. Okay, so if this is 10 and we want to go this way, getting larger, right? So you're getting larger, you multiply by 2, so it's 20. Okay? Now, if you're 20 and you didn't know this one, you would go backwards, right? And divide by 2, because it's the 2 side, right? So 20 divided by 2 will get you 10. So 10 goes to 20, getting larger. 20 goes to 10. So you multiply by 2, divide by 2. Okay? So that's one process. Now, the radical 3 process down here works with the base as well. So if you want to go this way, you're getting larger. So you multiply by radical 3. Up here we did radical 2, right? But here we're doing radical 3. So if this is 6, then we multiply by radical 3 and we get 6 radical 3. Okay? So that's getting larger, so we multiply by radical 3. Now, if we want to go back to this side and we didn't know that this was 6, then we would divide this by radical 3. These would cancel, and I would get my 6 back. If I wanted to go 6 to here, then this is the 2 side, so I'm getting larger, so I'd multiply by 2 and get 12. Okay? So if you started here and said 12, this is 6, because you got to divide by 2, then you're going to multiply to get the 6 radical 3. So you like on this process right here, basically you multiply to go this way or this way because you're getting larger each time. If you start from here and go backwards, then you're going to divide by 2 and multiply by radical 3. From here, you would divide by radical 3 and multiply by 2 to get here. You never go around dirty 30, okay? Now, that's a silly way to put it, but that helps people to remember you don't go this way around. So you either go here to here or here to here or just from here to here, okay? So it's simple. All right, so let's go to the notes. Anyway, so this is the short side. This is the 2x side, right? And this is the x radical 3 side. So to go here, I would multiply by 2. It's 28. Okay, to go here, I would multiply by radical 3, right? So it's 14 radical 3. Okay, so JH is 28, and SH, the bottom one, is 14 radical 3. Okay, short side getting bigger in both cases. Okay, so this one starts from the 2 side, right? So that's the 2 side. I'm getting smaller to go this way. So what do I divide by? Well, I divide by 2 because it's the 2 side. So 8 becomes 4. And then you're getting bigger, right? This is the radical 3 side. So 4 times radical 3 is 4 radical 3. Okay? So JS was 4, and this was 4 radical 3. Here, we're starting from the radical 3 side. This is the 2 side. This is the little short side, right? Okay, so if you want to get smaller to go get a short side, then you're going to take this 12 radical 3 and divide by radical 3, right? Okay, so those cancel, and this becomes 12. Okay, so now to get this side, I would have to get bigger, and it's the 2 side, so I'm going to multiply by 2 and get 24. So I divided by radical 3, and then I multiplied by 2. Okay, so JH was 24, and then JS, well, SH, I messed up. This should be JS on this one. Okay, so JS is 12. Okay? Now, Now I'm trying to flip it around. You know, like this thing's going to be all flipped around now. It's going to be more like that, okay? So that's the radical 3 side, right? That's the longer leg. That's the hypotenuse, right? So that's the 2 side. So you have to kind of keep up. Okay, that's the 2 side. This is the short side, and this is the radical 3 side, right? Okay, so if you go from the radical 3 side to get this one, oh gosh, I don't have my calculator. Bummer, bummer. Anyway, can I just assume? Let's say it's 8. I'm at home trying to scramble to get this lesson together because my classroom's taken right now. So let's say it's 8, and then you go here and multiply by 2, because what you did is say 15 divided by radical 3, and that's, 1.7, 15 divided by 1.7. Good grief. Probably 8, 9, 10, somewhere in there. Okay, so that's 8, and this becomes 16. Okay, know that that's not exactly right. Okay. Now this one is on the short side, right? So if I wanted to go this way, this is the hypotenuse, which is the 2 side, right? This is the 2 side. Okay, see the 2 side? It's sitting like this. So we're going from here to here, you double it, and that's 62. If you go this way, you're getting bigger as well, and it's the radical 3 side, so you say 31 radical 3. Okay? All right. Is this a 30, 60, 90? No. And notice how all these had just one number on them, okay? This one has 2 numbers. So if you have 2 numbers out of 3, Pythagorean theorem. Is this the adding or subtracting Pythagorean theorem? Adding, because you're trying to find the hypotenuse, okay? So you do square root of 6 squared plus 4 squared. What is that? 36 and 16, 52. So it's a little over 7, 7.1 maybe, okay? Here, this one's a little tricky. To go this way, you're multiplying by 2, right? Because that's the 2 side. So 4 radical 3 times 2 in front, because they're both outside numbers, is 8 radical 3, okay? So SJ is 8 radical 3. To go this way, you're getting bigger, so you're going to multiply this by radical 3. So 4 radical 3 times radical 3. Radical 3 times radical 3 is 3, okay? And then 3 times 4 is 12, okay? All right, so this one down here, you're going small from the 2 side, right? This is the 2 side, so you're going to divide by 2, so that's 50, and then you're going to multiply by radical 3, so it's 50 radical 3. And I know y'all can plug those in. All right, here, this is 25, and here's one of those where I need the calculator and I don't have it. Going backwards, 25 divided by radical 3, we'll make a guess and say it's 15, okay? Sorry, I'm having to do this that way, but just understand I divided and I get some decimal, and then 15 goes to here, you get twice as big because this is the hypotenuse, this is the 2x side, right? So 15 times 2 is 30, all right? Okay, so here we go. Let's see, a couple of application problems. Here we go. Equilateral triangle, all the sides are congruent, right? And so one of the sides is 20, so that's 20, 20, and then 20 down here, but we know that's 10. So I could use, to find the height, this is the height, I could use the adding Pythagorean theorem. 20 squared minus 10 squared, but it takes longer. Because really, isn't this a 30, 60, 90? In an equilateral triangle, all of these are 60, right? And this is 60 up here, but if you split it in half, that's 30. So it's a stand-up 30, 60, 90, isn't it? Okay? So if you want to go here, you divide by 2, see how that worked? And then here, you multiply by radical 3, so the answer is 10 radical 3. Bam! You know what the answer is immediately. All right? So this one says the perimeter is 120, so basically we got to find what one side is, okay? So we take the 120 and divide by 3, and we get 40, right? So each side is 40. 40 down here and 40 over here because it's equilateral, right? So we need the height. So we're going to do 40. Now remember, this is a 30, 60, 90 standing up, okay? A stand-up 30, 60, 90. So 40, this is the 2 sides, so we're going to get smaller. We divide by 2, we get 20, okay? From here to here, you got to multiply by radical 3, so your answer is 20 radical 3. If you didn't remember how to do that, then all you do is do the adding or the subtracting Pythagorean theorem, where you say 40 squared minus 20 squared, and that'll get you the same decimal answer anyway. Okay, the height of this triangle is 40 radical 3, and it wants to know what the length of a side is. Okay, so if I want to go to get this half side, then we know it's a 30, 60, 90, right? So I got to divide by radical 3. So I'm going to take 40 radical 3 and divide by radical 3, because that's the radical 3 side getting smaller, divide. So those cancel. This is 40. So one side is 80. So what is the length of a side? Well, 80. Okay, so that's one answer. And then what is the perimeter? Well, 80, 80, and 80 is 240, right? So 240 for the perimeter, okay? And then for one side, it's equal to 80. Easy enough? All right, the height of this thing is 8 radical 3, and it says, what is the area? Well, that's base times height divided by 2, or 1/2 base times height, whichever you like. I like this one better. So I need a base and a height. Okay, the base is all the way across, so I got to take this one back and say 8 radical 3 divided by radical 3 to get this short side. So those cancel, and I get 8 here. Okay, 8 and 8, that's 16 for the base. Okay, so 16 goes in for the B, right? And then the height is 8 radical 3. So it's, okay, 16 times 8 radical 3 divided by 2. Okay, the outside numbers, what is that, 128? Yeah, 128 radical 3 divided by 2. And then the outside numbers still work together to get, I hope I wasn't off the page. What is that, 64 radical 3? And so that's your final answer for the area. You know, if it was centimeters, then it would be centimeters squared. All right. Thank you very much.